Today we are here to discuss a case study on a closed loop control system. So can you give some application so that we can go with that application and discuss that application in detail? Any application for closed loop system?
Soil irrigation.
Soil irrigation. Okay, that we
Closed
will,
loop.
yeah, we are seeing in day-to-day life soil irrigation concept we are very familiar, right? So we can take it as with the closed loop system. So can you tell me what are the elements found in closed loop systems?
Sensors.
Sensors, very good.
Actuators.
Actuators.
Controller.
Controllers.
Feedback.
Feedback, very good. The main thing different
Input.
between open loop and closed loop is feedback, right? Okay, next. Controllers. Set points, yes, set points are definitely important thing to find out the error. So these are the main elements, right? Can you tell me which are the inputs and which are the outputs here?
Sensors input.
Very good. Sensors will be my input, always input. Next, output,
Actuators.
actuators. Right. So these are the supporting system for my closed loop. Now tell me what will be doing in your soil irrigation. What is the basic process of soil irrigation?
Soil, we will checking the humidity and temperature for agriculture. So if we use this closed loop system, we can preset the values, like temperature and humidity values. If we preset, it will compare the sensors will give the input, and the actuators will be operating it, So by using that supporting system like feedback and controller, we can compare the input, So if the preset values and the input is similar, we can pass the signals to output, and it will maintain that soil temperature or moisture.
Moisturizer. Very good. So basic thing is I have to maintain my soil components, right? Like temperature, humidity, moisturizer. That basic components to be maintained. So let me know what will be the basic input we are giving to the soil. First we can draw a block diagram or generic architecture of a closed loop system for this same soil loop irrigation. So what will be the input which we give to the soil? Water or minerals, whatever it may be, nutrients. So this acts my input to my soil, right? So from the soil, what are the parameters we are going to check? Few parameters. Yes, temperature, humidity or pH value of a soil will be obtained, right? Using what?
Sensors.
Here act my sensors, right? From this sensor, I am getting this value, but what is the purpose of getting this value?
Preset
To check and to
maintain the
my moisturizer. So I am giving this input to my controller. So controller's work is to preset is nothing but your set point. So I am giving the set point of my temperature and humidity. So I am going to get the input from the soil, and I have the set point. My controller is going to compare the both the points, and that will give my feedback. So for example, if my temperature is 50 degree, right? My set point temperature is 60 degree. Or we can take it like my set point is 40 degree. So it's more than enough, right? Temperature is 50 degree and here it's 40 degree. It's 10 degree above. So I have to cool down my soil. So I have to give the feedback like minus 10 degree. That only gives my set point. So I am giving the feedback like reduce your degree, that to be 10 degrees Celsius, and this set point will be given to my actuator. So here comes my actuator. Here comes my actuator. So the supply will be here, but depending upon my feedback, the supply will be regulated. Okay. So this can be your rough draft or rough diagram of your soil irrigation using the closed loop. And now we can check whether I have a sensor. These are the closed loop components, right? I have to check whether my diagram is correct. So we have sensor, yes, we have sensor to measure the temperature, humidity and pH. Whether we have actuator, yes, we have actuator here to regulate my water or nutrient supply. Next, looking for my feedback, yes, I have a feedback system which is controlled by my controller. Controller, yes, I have a controller, and this controller may be your Arduino, ESP, ARM or whatever. Depending upon your efficiency, you can choose your controller. Next, set point, yes, obviously we have a set point to regulate my process. So I have all my closed loop components, and the rough draft of my closed loop for the soil irrigation is obtained. Is there any doubt?
Oh.
So can anyone conclude the diagram alone?
And first, in this system, in this we are using soil irrigation using closed loop system. For that, we need a base source soil.
Yes.
For that, we are giving input as water or nutrients.
Nutrients.
To actuate that, we are using actuators.
Good.
To get the signals, we are using sensors to keep on regulating and keeping the soil moisturizer. So by getting the signals, we are giving that signal to controller. In that controller, we will be having a set point of 40 degree. If the getting signal is 50 degree, then signal for feedback is it should cool down the soil so that it sends the signal minus 10 degree. From that it goes to actuators and sends some water and complete the soil by cool down.
Very good. So this is your complete structure. The same closed loop can be applied for any other application. The process is very simple. You have to know what is your input and what is your output, what is your set point and what process you are controlling. So if those parameters are clear, you can easily draw your closed loop control system for any application.